In physics experiment, measuring sound and heat is also to be considered as a safety measure that can help prevent fluctuation in data recording. Measuring precise and accurate data is beneficial to an experiment that can be potentially used for practical application. Just even the slightest marginal error can be fatal, such as a small deviation in from the designing a railroad can derail the train car, potentially killing the passengers. The sound captured by the meter is evaluated also within the device, which makes it a very reliable and portable way of measuring noise meter or decibels. A sound level meter uses a microphone to capture it. The decibel meter is a measuring instrument used to assess noise or sound levels by measuring sound pressure.
Personal noise dosimeter is an intrinsically safe, small, lightweight that provides real-time personal noise exposure readings. It is an instrument that measures the direct noise exposure of an employee, and it is placed on their collar close to their ear, and it stores the noise level information. At ginagamit din ito upang malaman kung saan nagmumula ang mga problemang ingay at para na rin sa mga sa health ng mga employee.
It turns the sound wave onto electrical energy. When the diaphragm is hit by sound, it vibrates, causing to pass the energy to the other components of microphones and converts the vibrations to electrical current that will eventually become the audio playback. Pressure field microphone. This instrument is used for measuring the actual sound pressure present in the surface of the microphone's diaphragm. This is usually used in a closed coupler or the measurement of sound pressure at a boundary or wall. Frequency analyzer comes in different forms, such as computer, portable, and traditional, that has its own advantages and disadvantages for RF purposes. In using this equipment, we must consider the center frequency that shows accurately the wavelengths from the center to its peak and the sides. A minimum of 20 decibels is suggested or required for precise and accurate measurements. It also contains functions such as resolution span, resolution bandwidth, markers, phase noise for parameters of oscillators, spectral mask for certain limits, spurious signal detectors. It is also important to consider the equipment's capabilities like discovering, triggering, capturing, and analysis of signals to avoid miscalculations and uncertainties. Frequency analyzer or spectrum analyzer. It provides information about the spectrum of a signal and its wavelength from its amplitude and time. Its main application is spectrum signal observation and audio analyzing.
Next is laboratory thermometer. A laboratory thermometer is used to measure the boiling point and freezing point during science experiment. Thermometer. What is thermometer? From the word thermometer. Thermometer is used to measure a temperature. And this type of thermometer it is used to measure the high accuracy liquid, and it is commonly used for a laboratory experiment. And these types of Thermometer. This thermometer cannot be used to measure the human body temperature. And next is pyrometer. Pyrometers are ideal for taking accurate measurements of temperature without contact. Pyrometer. What is pyrometer? It is a type of a measuring relatively high temperature. Most pyrometers work by measuring radiation from the body whose temperature is to be measured. Um, the advantage of this device is when you're measuring a material or anything, you will not having to touch the material to be being measured.
Thermocouple. A thermocouple is a thermoelectric device used for measuring temperature. Typical thermocouple is made up of two dissimilar metals joined together to form the two junctions, which is hot junction and cold junction. Hot junction is placed on the surface or in the environment that is being measured, while cold junction remains at a known constant temperature.
Langmuir or electrostatic probe is a metal wire placed in a plasma to measure current and voltage. Langmuir probes enable the temperature, electron, and ion densities to be measured.
Infrared sensor. An infrared sensor is an electronic device that measures and detects infrared radiation in its surrounding environment. Infrared radiation was accidentally discovered by an astronomer named William Herschel in 1800. While measuring the temperature of each color of light, he noticed that the temperature just beyond the red light was highest. Infrared is invisible to the human eye, as its wavelength is longer than that of visible light, though it's still on the same electromagnetic spectrum. Anything that emits heat, everything that has a temperature above around 5 degrees Kelvin, give off infrared radiation. There are two types of infrared sensors, the active and passive. Active infrared sensors both emit and detect infrared radiation. Active infrared sensors have two parts, a light emitting diode or LED and a receiver. When an object comes close to the sensor, the infrared light from the LED reflects off the object and is detected by the receiver. Active infrared sensors act as proximity sensors, and they are commonly used in obstacle detection systems, such as in robots. Passive infrared sensors only detect infrared radiations and do not emit it from an LED. Passive infrared sensors are comprised of, first, two strips of pyroelectric material. Second, an infrared filter. Third, a Fresnel lens. Fourth, a housing unit. Passive infrared sensors are most commonly used in motion-based detection, such as in home security systems. When a moving object that generates infrared radiation enters the sensing range of the detector, the difference in infrared levels between the two pyroelectric elements is measured. The sensor then sends an electronic signal to an embedded computer, which in turn triggers an alarm.
resistance temperature detector. They use carbon or platinum sensors to detect changes in electrical resistance. These changes are caused by temperature changes, and the changes are predictable. An RTD consists of resistance element and insulated copper wires. The most common number of wires is 2, however some RTDs have 3 or 4 wires. It is usually platinum because as a material it is highly stable over time. It has a wide temperature range. Nickel and copper are also other choices of the material for the resistive element. And how does it work? An RTD works by using a basic principle. An electrical current is passed through the sensor. The resistance element is used to measure the resistance of the current being passed through it. As the temperature of the resistance element increases, the electrical resistance also increases. The electrical resistance is measured in ohms. The resistance value can be converted into temperature based on the characteristics of the element. Typical response time for an RTD is between zero point 0.5 and 5 seconds, making them suitable to application where an immediate response is not required. Benefits of using RTDs over the temperature sensors: highly accurate, consistent, offer long-term stability, high repeatability, suitable for extreme environments, have a high temperature range. And RTDs are used within different industries including automotive, white goods, marine, and industrial application.
Conclusion: measurement is the key to a successful experiment. Knowing how to measure is a core skill, and knowing how to use those instruments is also a skill. Recognizing and familiarizing these things will be beneficial for future experiments and can be applicable to other branches of science.